Hello AP Calculus students, this is Mrs. Stipe and the first of 3 videos on U substitution. I hope that by the time you watch all 3 of them that you are an expert in this procedure. When we take the integral of a quantity and it's something complicated such as 2x times the quantity x squared plus 9 to the 4th dx, we remember that in integration we don't have the tricks, the properties that we do with differentiation. There is no product rule. We do have U substitution, and U substitution really is a form of chain rule in reverse. Okay? Here's how it works. The first thing we do is we pick the U. And the hints for picking the U is that you want to look for that function that's the innermost function, the one that maybe is being taken to the 4th power, or maybe it's the power of the base e. It could be under a square root. The best I can tell you is that the way you get really good at picking the U is by doing lots and lots of U substitution problems. So here we go. U is going to be x squared plus 9. When we take the derivative of both sides with respect to x, we get du dx on the left and 2x on the right. Moving that dx over, we now have du equals 2x dx. At this point we're ready to rewrite the original integral, and we recognize that x squared plus 9 to the 4th is nothing more than u to the 4th, and then 2x dx is du. So we went from a really complicated integral to something that is super simple to integrate, and that is we get u to the 5th plus c. The last step of a U substitution problem in this case is substituting back in the value of u, and so what we get is x squared plus 9 over 5 plus c. Now we know that when we've integrated, the one way we can check to see that we did it right is to take the derivative of our answer and see if we get what we started with. So let's go ahead and do that. I'm going to put the 1/5 out in front because I think that's easier. I don't want anybody to be thinking they need to do a quotient rule here. Oh, I left off a 5th power here, so go back and make sure you write that down correctly. Great. So when I take the derivative of this, I get 1/5 out in front, right? Here's the chain rule. So we take the power 5 times the inside function, we bring it down a power, and then we multiply by the chain, right? When we clean all this up, we get 2x x squared plus 9 to the 4th, and so we know we've done the integration correctly because taking the derivative gets us back to the original function. Okay, good. Here's the next example. What about if the u happens to be the argument of a trig function? So let's try 3x squared times the sine of x cubed dx. So we're going to pick u to be x cubed. That means du dx is equal to 3x squared. We move the dx over and we get 3x squared dx for our du. So here comes the u substitution. So if u is x cubed, then the sine of x cubed is the sine of u. And we have a 3x squared dx left, so that's nothing more than du. So the antiderivative of the sine is the negative cosine, right? And then last step we go back and we replace the u with x cubed, and that's our answer. Okay, what do you think so far? Not bad? Let's do one that's a little bit more challenging. This time we're going to take the integral of x cubed times the square root of x. Sorry, I had that wrong. X squared times the square root of x cubed plus 1 dx. So the u is going to be what's underneath the square root, x cubed plus 1, and so du dx equals 3x squared, or du equals 3x squared dx. So when we're ready to do the u substitution, that's going to be the square root of u, easy enough. But do you recognize that du is not exactly equal to x squared dx? So we need to do a little bit more work here so that du and the x dx, x squared dx, we can replace the x squared dx. The way we do that is simply move that 3 over, right? So now we have exactly x squared dx, and so 1/3 du, and I always like to bring the 1/3 out in front of the integral, mainly because it makes it easier to integrate. Alright, great. So I'm going to rewrite this because taking the integral of the square root is tricky. So I want to think of the square root as u to the 1/2 power. Remember, when we've gone from this step to this step, we have not actually integrated yet. So here's the power rule. We raise the 1/2 power to the 3/2, and then dividing by 3/2 is the same as multiplying by 2/3, right? And so last step, clean this up and put the u back in, and the u was x cubed plus 1. So final answer is 2 parentheses x cubed plus 1 to the 3/2 over 9 plus c. Okay, great. I hope those simple beginning u substitution problems were helpful. In the next video, we'll talk about instead of indefinite integrals, we'll have integrals with bounds, and we'll work on some trickier problems. Okay, thanks for joining me. See you in class.